we're going to take the derivative of this function, saying 5x plus 4 to the fourth times 2x plus 1 to the negative third power. So what we have going on is a product rule. So just write the formula for that product rule, f times g prime plus g times f prime. And my f of x is 5x plus 4 to the fourth, and my g of x is the 2x plus 1 to the negative 3 power. What makes this product rule special is that the functions that are being multiplied are going to be chain rules. So that first function, 5x plus 4 to the fourth, that's a function within a function. And same thing with your g of x, your second function back here. That's a function within a function. Okay, so let's take the derivative of the first function, 5x plus 4 to the fourth. The inside of that function is 5x plus 4. The outside is something to the fourth. So if you take the derivative of the outside, you get 4 times something to the third power. Okay, so I just took the derivative of something to the fourth, right? So if it was x to the fourth, you would get the derivative being 4x cubed. Well, I got 4 times something cubed. I then write down my inside of 5x plus 4, and you multiply by the derivative of the inside, which is 5. And that gives us 20 times 5x plus 4 cubed. And the derivative of g, the inside is 2x plus 1. The outside is something to the negative third power. So the derivative of the outside is negative 3 times something to the negative 3 minus 1, so negative 4 power. You then write down your inside of 2x plus 1 and multiply by the derivative of the inside, which is 2, to get negative 6 times 2x plus 1 to the negative fourth power. So now we're ready to plug into our product rule. So far with the product rule, I have the first function, which was 5x plus 4 to the fourth, and I just copied and pasted that down, times the derivative of the second function, which we found to be negative 6 times 2x plus 1 to the negative 4. So I just kind of copied and pasted that down again. I overuse parentheses sometimes. I use them correctly, but I just like to kind of block everything off and see each factor. So that's why I have that negative 6 in the parentheses. And for the rest of that product rule, we have plus g, so I just copied and pasted g of x. And then the derivative of f was this 20 times 5x plus 4 cubed. And so I kind of copied and pasted that there. From here, I want to simplify this out. I have two sides, right? A left side and a right side, and that plus sign is what's separating it. So I want to see if there is a GCF. If you will look, there is a 5x plus 4 to the fourth and a 5x plus 4 to the third. So there's a 5x plus 4 on both sides of that plus sign. So I can take out a GCF of 5x plus 4 to the lowest power that we see, and between 4 and 3, 3 is the lowest power. So I also see a 2x plus 1 on both sides of that plus sign, and we're going to take out the lowest power. And negative 4, negative 3, the lowest power we have there is negative 4. And I'm also going to decide to take out, looking between the 6 and the 20, I guess a negative 2, because 6 and 20 both have a 2 that goes into it. And I just chose to use a negative 2. It didn't have to be negative necessarily. So what we're doing now is we're going to divide each side by the GCF. So let's start with this left side. If I say 5x plus 4 to the fourth power divided by 5x plus 4 to the third power, the rule with your exponents is to keep the base, subtract the exponents when you're dividing. So the base that I'm left with is 5x plus 4, and the fourth power minus the third power when we're dividing just gives us a first power right here. I'm not even going to write a 1. Okay, now 2x plus 1 to the negative fourth divided by 2x plus 1 to the negative fourth, that's just 1. So, I mean, I could write a factor of 1 right there, but that's not needed. Anything times 1 is itself. And now I'm just going to say negative 6 divided by negative 2 to get a positive 3. Now on the other side, I can say 2x plus 1 to the negative 3 divided by 2x plus 1 to the negative 4. Well, the rule when dividing is to keep the base, subtract the exponents. So the base is 2x plus 1. And if I say negative 3 minus negative 4, so that's minus a negative. Negative 3 minus negative 4 is actually positive 1. So that's to the positive 1 power. Okay, now I say 5x plus 4 cubed divided by 5x plus 4 cubed. That's just a factor of 1. So anything times 1 is itself. And now I'm just going to say 20 divided by negative 2 to get negative 10. So at this point, look at the GCF. The GCF that I pulled out is factored, right? It's something times something times something times something. Okay, well, the only thing I need to simplify at this point is the fact that what's inside of these brackets can be distributed and combined. Okay, so I get, when I distribute out inside the brackets 15x plus 12, and then I had to distribute a negative 10 to the 2 and to the 1. So I get negative 20x, and I see a mistake right here. This is supposed to be a negative 10, because 1 times negative 10 is negative 10. I can still combine like terms to get negative 5x plus 2. And now I'm going to write my 5x plus 4 cubed. I'm going to put the 2x plus 1 in the bottom, and so that will be to the positive 4th power, and then I'll just put a negative 2.